Welcome back to another video lesson on multiplying and dividing rational expressions. I hope that the video quality and audio quality is improving as we continue to learn online. And for today's lesson, we want to start by recalling everyone's favorite type of number, fractions. Because the way we multiply and divide rational expressions is the same as the way we multiply and divide fractions. So let's go over that for those of you that have perhaps forgotten. So let's go with the example 1/3 multiplied by 2/7. How do we multiply fractions? Well, very simply, we multiply the top by the top and the bottom by the bottom. So, 2 times 1 is 2, and 7 times 3 is 21. Then we may try and simplify if we can. Here we cannot, so that is the most simple form. So this is how we multiply. How do we divide fractions? Let's take, for example, 4/5 and divide it by 7/2. I would like us to recall that the way we divided fractions was to change it into a multiplication statement. We had a very funny way of saying that called the kiss and flip method. So we keep the 4/5, we multiply, and then we flip the second fraction. So now we turn it into a multiplication statement, which we already know how to do. So 4 times 2 is 8, 5 times 7 is 35. And that cannot be simplified further, so we are finished with our recall of how to multiply and divide fractions. Now what we want to do is a few examples on how to do this with rational expressions. So we'll start with 4x cubed minus 8x squared divided by 6x squared minus 18x. Now this is not really the division that we're talking about. We're going to take an expression like this and multiply it by another rational expression. So this gets pretty ugly pretty quickly. However, the first step is to very simply factor everything that you can. So systematically go through the top and the bottom of each rational expression and factor those polynomials. So, for example, the first one turns into 4x squared multiplied by x minus 2. And the second polynomial turns into 6x multiplied by x minus 3. You can always common factor out and then kind of ask yourself, did I do that right? So 4x squared multiplied by x, that would be 4x cubed. Often just checking that multiplication helps you confirm your thought process. We'll do the same thing here, so x squared minus x minus 6, that should be x minus 3 multiplied by x plus 2. Those multiply to -6 and add to -1. And then lastly, we have x minus 2 multiplied by x minus 2. Add to negative 4, multiply to positive 4. So once we've factored everything, we very simply, if we recall, we multiply the top by the top and the bottom by the bottom. What we didn't have to do with fractions was we could always simplify. We know what 4 times 2 is. But we could easily write this fraction here as 4 times 2 divided by 7 times 5. And just keep those, factors on the top and the bottom respectively. So that's kind of what we do with multiplying and dividing rational expressions. So we kind of make one big fraction, and we have 4x squared, x minus 2, x minus 3, x plus 2, all divided by 6x, x minus 3, x minus 2, and another x minus 2. And so now we kind of have everything in one rational expression. This is where the fun begins. Now we can start to cancel things out. So it has to be exactly the same on the top and the bottom. So for example, I can easily cancel out the x minus 2 with another x minus 2. And the same can be said of the x minus 3 and the other x minus 3. So that all cancels out. That they divide through by each other. Anything divided by itself is just 1. So we get a multiplicative factor of 1, and anything multiplied by 1 is itself. So we actually can just cross them out and forget they existed. Is there anything else we can cross out? Well, we can say 4 over 6 and just reduce it to 2 over 3. So that's a thing we can do in the next step. But x squared divided by x, I can cross out 1 power of x and just have x left on top. So our fully simplified rational expression looks like 2 over 3 x on the top multiplied by x plus 2, and then on the bottom is a multiplication of x minus 2. And so all of this simplified like so. Our next step is once we believe we are done simplifying, and in this case, I believe we are, we can very simply state our non-permissible values. So what is x not allowed to be? Well, x cannot equal, from this right here, positive 2. And that's the most obvious one. And even though I said we can cancel these out and forget they exist, we can only forget they exist until we have to look at the non-permissible values, because this is a simplified version of our original statement. And so all of the things on the denominator here were not allowed to equal 0. That means all the things on the denominator here were not allowed to be equal to 0. Even though I cancel them out, you still have to say x cannot equal, positive 2 covers this, positive 2 covers that. Positive 3 covers this particular expression. And then the thing that would make the whole denominator 0 here is if x were equal to 0. So we have another non-permissible value there of x cannot equal 0. So if we go back to, and that one's a little tricky to see, but if we go back to here, 6 times 0 squared, well, that's 0 subtract 18 times 0, and that's 0 subtract 0. So the bottom would be 0 there as well. And that's, math doesn't like that, so we have to make sure we list those values here. So that's our first example, and we'll move on to example number 2. And we'll do a little bit of division here. Let's try out x squared minus 9, x squared minus 4x divided by x squared plus x minus 6 So that's what we will try to divide. And so step 1, just like multiplication, is still let's factor everything. We'll get the fully factored form of these two expressions. So once we have that factored, we can then start to use our rules for multiplying and dividing. And for division, it was to change it to a multiplication statement and then flip that second expression. So let's do that now. First one stays exactly the same. Change to multiplication, and no, it's multiplication, but let's just get rid of that. So now those two expressions come on the top, and the ones that were on the top are now on the denominator. So with that being said, I'm going to put a star right next to there, just so that I remember to come back to it, because it's kind of important. That step has some of its own restrictions. So now we have a multiplication statement, and we combine everything, x plus 3, x minus 3, x plus 5, x minus 4, x minus 4 on the bottom, so I'm starting to see that that's going to cancel. And x on the bottom as well, so we'll put that there. X plus 3 on the top, and x minus 2. And so now I'll begin to look for things that can cancel out. So x minus 4, like I said, x plus 3, and I think that's everything. So our simplified version looks like x minus 3 times x plus 5, all divided by x times x minus 2. So that's what we're left with. And once we get to the end there, we have to state our non-permissible values. So what can x not be equal to? Well, x cannot equal 0 from that expression right here. X cannot equal positive 2 from right here. Both of those values will make the denominator 0. For example, 0 multiplied by negative 2, when this x is 0, would still be 0. And then 2 multiplied by 2 subtract 2, well, 2 multiplied by 0 is still 0. So that also will be equal to 0. Now, we saw it before in the last example. The things that cancel out are important. So here, x can also not equal positive 4. So this is not allowed to be 0 here. So 4 minus 4 makes that so. Also, x cannot equal negative 3. And so I think that covers our basis for everything here. So far we have 4 non-permissible values, and we always have to check with the star. Because we did something, we kind of hid a non-permissible value, and we did this change to multiplication. When we flipped, we took something that was on the bottom and put it on the top. So what we kind of can sometimes forget about is that x is not allowed to equal negative 5 here, because that would make this expression 0, and this whole denominator would be 0. So when that occurs, we have a non-permissible value. So from right here, essentially, if we want to look at it, that's an expression that's important and will be a non-permissible value. So is x minus 4. So is x. Another x minus 4 here. So that's covered twice. That actually canceled in the end. And I think that covers all of them except for x minus 3 here and x plus 2. X plus 2 is here and x minus 3 is here. So the bottoms here were non-permissible values. We had to check. The bottoms here, because if I try to divide by something and that something has a denominator of 0, I can't do that. But then if that something I'm dividing by has a numerator of 0, let's just play through this a little bit. 2 would probably be the easiest one to pick. So if I put x is equal to 2 here, I would have 5 times 0 all over 7. It's 2 plus 5 multiplied by negative 2, which is 2 minus 4. And that equals out to be 0 over negative 14. Well, 0 divided by anything is still 0, so I would be dividing this. This first expression would be divided by 0 in the end. And that's also not allowed. So that's why we have a non-permissible value for the expressions that are on the top here. Okay, let's do one more example. We shall do 2r squared minus 7r minus 15 divided by 4r squared minus 9, which is itself divided by 3 subtract 2r. Okay, so we have we have a lot of accounting to do here. So let's begin by factoring everything. That's almost always our first step. I'm going to leave that top one because it's decomposition, and I know it's going to take the longest. I don't want to do it right away, so I won't. I'll do the difference of squares twice here. 2r minus 3, 2r plus 3, 3 subtract 2r. Okay, so now we'll do this decomposition here. 2 times negative 15, that's negative 30, which leads us to negative 10 and positive 3. So we have 2r squared minus 10r and positive 3r minus 15. And so when we factor, we get 2r multiplied by r subtract 5. 5 times 2, yeah. Okay, and then here we also get 3 multiplied by r subtract 5. Okay, so our factors on the top are r minus 5, that's here, and then 2r plus 3. This looks like it might turn out very nicely. So we have all our factors. We'll do a couple steps in one now. So on the top we have r minus 5, 2r plus 3, and then we're going to end up multiplying by 3 subtract 2r. So that's going to be on the top now. And on the bottom will be r minus 5, r plus 5, and then these two terms here. That is what you should get after you do the kiss and flip, which, by the way, has a more technical term, multiply by the reciprocal. Didn't feel like you'd remember that in grade 9. So, what we have here, it looks like a lot of things are going to cancel. So, r minus 5 is going to cancel. 2r plus 3 is going to cancel. So far, it looks like I have 3 minus 2r over r plus 5 times 2r minus 3. And this would be at the point where I might assume it's done, but here's a kind of cool little trick. These are so close to being exactly the same. They almost look to be out of order. So what we can do is we'll factor something out of the top number. You might say, well, they don't have anything in common. And I'll say to that, they have a negative 1 in common. So negative 1 multiplied by negative 3 would give me positive 3. And negative 1 multiplied by positive 2r would give me negative 2r. So that will be our new top expression. It looks a little bit more complicated, but there is a reason behind that, and that's because now we'll just rewrite positive 2r subtract 3. These are now exactly the same. The 3 is negative, the 2r is positive, and so that can cancel out as well. And we are left with negative 1 divided by r plus 5. That is our most simple expression that came from these. So let's go through our non-permissible values. What can, oh, not x, but what can r not be equal to? Like I said, it's basically from this stage here. That's where I usually look. So r cannot equal positive 5 or negative 5. That covers those two. R cannot equal this expression right here would be negative 2r plus 3 is equal to 0. So negative 3 over negative 2, which is positive 3 over 2. So just account for things here. That's done, that's done, that's done. This is the same non-permissible value as this. And then negative 3 over 2 should be that one. So negative 3 over 2 as well. It would seem that there are only 4 non-permissible values. 2 from here, 2 from here, and then this one is the same as one above. So that's what I have. That will be our last example, and that will be all for our video on multiplying and dividing rational expressions. Good luck, and feel free to ask questions should they arise.